What if we're asked to find the point of intersection between two equations? Let's say those equations are 3x minus 4y equals 7 and 9x plus 8y equals 11. Where would these two lines cross if we were to graph these lines and then figure out where they're crossing? Well, there's a couple different methods we can use. Let's start off by using elimination. So to use elimination, I want to cancel some things out, right? So I'm going to write this 9x plus 8y equals 11 right here. Equals 11. And I'm going to write the second equation down here, but instead of writing it the way it is, I'm going to multiply it by 3. So that everything in here gets multiplied by 3. So instead of 3x, I have 9x. Instead of minus 4y, I have minus 12y. And instead of 7, I have 21. Now that the coefficients in front of my x values are the same, they're both 9, I can subtract these two lines and those x values will cancel out. So let's see what happens. 9x minus 9x is 0. 8y minus negative 12y is the same as 8 plus 12y, which will become 20y. And 11 minus 21 will be negative 10. Okay, now let's solve for y. Right now we have 20y equals negative 10. Divide both sides by 20. Y equals negative a half. And then to find the x value, you can just plug that into one of the original equations. Like let's say you want to use 3x minus 4y equals 7, and you want to plug that value in for y. We can do that. So 3x minus 4 times negative a half equals 7. Okay, so we simplify this first. 3x plus 2 equals 7, right? Negative 4 times negative a half is plus 2. Bring that 2 to the other side. 3x equals 7 minus 2, which will be 5. Divide both sides by 3. X equals 5 over 3. So the point that they intersect is 5/3, comma, negative a half, right? Your x and y values. That's the point of intersection. That's your answer. And so really what we did here was we used elimination to figure out, this relationship and to solve for y. And then we used substitution to plug that answer into one of the original equations to get the x value. So really this was elimination and substitution working together, right? We did elimination to find y, and then we did substitution to find x. So it's perfectly okay to use a combination like this, where you use a little bit of this, a little bit of that to get your final answer. But let's say we wanted to use just elimination, right? Just elimination. How could we do this? So I want to find x and y without substitution at all, just elimination. Well, let's write our equations out. So we have 9x plus 8y equals 11. And I'm going to write the other equation here, right? It used to be, here, let's put it on top, 3x minus 4y equals 7. I'm going to bring it down here, and I'm going to multiply it by 2. So you get 6x minus 8y equals 14. So instead of this version of the equation, I'm going to use this one, right? As long as you multiply both sides by the same number, you can do that. So now these are my two equations, and I'm going to use elimination again. I'm going to add them together because 8y plus negative 8y, those will cancel, right? Those are going to make 0. So 9x plus 6x is going to be 15x. 8y plus negative 8y is 0. 11 plus 14 will be 25. So you're allowed to add these together or subtract them, whatever you want to do, whatever works, right? In this case, I'm going to add because that's what causes these to cancel. Now I have 15x equals 25. Divide both sides by 15. X equals 25 over 15, which you can simplify to be 5 over 3. So x is equal to 5 over 3. So that's how you could find your x value, right? We already found the y value using elimination up here, right? That first elimination we did was to find y. You just set up another elimination to find x. So if you want to use just elimination, you do that first part from the last one, and then you would do this part to find x. If you want to use a combination of elimination and substitution, you could use elimination at first to find one variable, and then substitution to find the other. You could also use just substitution. Just substitution. How would I do this? Well, let's say I have my same equations, right, just to keep it simple. 3x minus 4y equals 7. That's one of them. And then you have 9x plus 8y equals 11. So for this first one, let's isolate x. Right? I'll bring my 4y to the other side, so 3x equals 7 plus 4y. Divide both sides by 3. X equals 7 plus 4y over 3. And I'm just doing this so that now I have a definition for x, right? X is equal to this. And then over here, what you can do is you can substitute that in. So you take this definition for x and you plug it in for x over here. So you get 9 times 7 plus 4y over 3 plus 8y equals 11. So I just replaced x with this big thing that equals x. Okay? And then you multiply it out. 9 over 3, that's going to be 3. So really what you have here is 3 times 7 plus 4y plus 8y equals 11. You expand this. 3 times 7 is 21. 3 times 4 is 12y plus 8y equals 11. Move your 21 to the right. 12 plus 8y, it's going to be 20y equals 11 minus 21, negative 10. Just like that. Divide both sides by 20. Y equals negative a half. So same answer that we got as when we use substitution, right? So it doesn't make a difference which way you do these questions. And then of course you could solve for x, right? You could take this definition and plug it into the y value for this. So you just plug that back into here. So x is equal to 7 plus 4 times your y value, which is negative a half, divided by 3. 4 times negative a half is negative 2. 7 minus 2 is 5. So you get 5 over 3. So again, the exact same answer for x that you get if you use elimination. Now, there's one other method you could use if you want, and that is solving it graphically. Graphically. And so what that means is we actually plot and graph the two equations in order to find the point that they intersect. So let's say you have 3x minus 4y equals 7. That's kind of in standard form, right? We talked about the forms before, but that's in standard form. You could rearrange this to put it into slope y-intercept form, right? Y equals mx plus b. If you do that, you move the 3x to the other side, you divide both sides by negative 4. We have a whole video on changing forms, but what you're going to get is y equals 3/4 x minus 7 over 4. If you change that into y equals mx plus b, that's what you get. The other equation, 9x plus 8y equals 11. If you put this one into slope y-intercept form, you get y equals negative 9 over 8x plus 11 over 8. So we now have these two equations that we can graph, right? So the first one we'll graph, the one on the left here. It has a y-intercept of negative 7 over 4. So you could say, all right, negative 7 over 4, put it there. It has a slope of 3/4, that's positive. So it's going to be going up, like that. This graph on the right, you have 11/8 is the y-intercept. You put that up here. 11/8. And that has a slope of negative 9 over 8. So it has a negative slope. So it's going to be going down like this. And so if you're doing this on a grid, right, on your grid paper, and you're doing it to scale, and you draw these lines, properly, you graph them properly, you should be able to see that the two lines are going to cross at a very specific point, right? The x value will be 5/3, and the y value will be negative a half. Just like that. So if you graph this to scale, if you graph it properly, right, you put your y-intercept and then you find like the next point using the slope, right? So for this one, you go down 9 over 8, down 9 over 8, connect those points all with a line, do the same thing for this one. You can see where they end up crossing, right? And you should get a fairly accurate answer, right? 5/3 and negative a half. You might have to do some estimation, right? So this method isn't going to be as accurate as doing elimination or substitution, but you can still use it, just to confirm that you're doing things correctly, or if you're asked to do it this way, hopefully you get a nice clean answer that's easy to read. 5/3 might be a little bit tricky to read, but you can make your best guess based on where that point looks like it's located on your graph paper.